Welcome back to Le Podcast de Philippe. Today we're doing a deep dive into AI terms.
Yeah, AI is everywhere these days, and it seems like there's a new term every day.
So we've compiled a list of 25 of the most important terms for you guys that you wanted us to cover.
Yeah, we're going to break them down in a way that makes sense whether you're a tech expert or just curious about AI.
Exactly. We'll explain what these terms mean, why they matter, and how they impact you.
All right, let's kick things off with GPU clusters.
Okay, GPU clusters. So these are basically like the powerhouse behind those amazing AI models we're always talking about, right?
You got it. They're like massive teams of specialized computer chips working together,
Ah, okay.
crunching huge amounts of data at incredible speeds.
So like a super brain for AI, basically.
Pretty much. They're essential for AI to do all the cool things we see today, like generating realistic images or having natural conversations.
Okay, so like when I'm chatting with ChatGPT and it feels like it's responding in real time.
Right. That's the power of GPU clusters at work. Without them, we'd be waiting forever for responses.
Makes sense. But there are limits, right? Even with all that power, there's only so much information an AI can handle at once. That brings us to window of context.
Exactly. Think of it like how much information you can keep in mind during a conversation.
Okay.
AI has a similar limit. It's the amount of data it can consider when responding to your request.
The source material compares it to scrolling back through a WhatsApp conversation to understand the full context.
Yeah, the AI needs enough context to give you a coherent and relevant response.
Got it. So the window of context determines how much of the conversation the AI can actually remember.
Precisely. And this is why some AI models are better than others at handling long articles or complex tasks.
Makes sense. They have a bigger window, so to speak.
Exactly.
So we've got the raw power of GPU clusters and the memory capacity of window of context.
Right.
Now let's move on to fine-tuning. This is where things get really interesting because it's about customizing AI for specific jobs, right?
Yeah, think of it like taking a general-purpose athlete
Right.
and training them to become a world-class sprinter.
Okay, so you're taking this general AI and you're shaping it for a particular purpose.
Exactly. We fine-tune AI models to make them excel at specific tasks or domains.
So like in the source material, banks use fine-tuning to train AI to detect fraud.
Right. You could fine-tune a model to analyze legal documents, write marketing copy, or even compose music.
Ah, that's cool. So it's all about specialization.
It is. It's about making AI really good at a specific thing.
Got it. So we've got the power, the memory, and now the specialization.
Yeah.
But sometimes, even with all that, there's a delay in response.
Sure.
Like when you ask a question and you have to wait a bit for the AI to answer.
Right.
That's called latency, right?
It is. Latency is the time it takes for an AI system to process information and respond.
Okay. So what causes that delay?
Well, it could be the complexity of the task,
Oh.
the speed of the network, or even the distance between you and the servers where the AI is running.
So for things like voice assistants or self-driving cars, we need to minimize latency as much as possible.
Absolutely. Even a tiny delay could be a big deal in those situations.
Okay, that makes sense. Now let's get into RAG, which stands for Retrieval-Augmented Generation. Now this sounds like it's giving AI access to a whole lot more information.
It is. Instead of relying solely on its internal knowledge,
Okay.
Argly lets AI tap into external sources in real time.
So it's like giving AI a massive library to search through.
Yeah. Imagine a customer service chatbot using Argry to answer your questions directly from product manual.
Yeah, I see how that could be super useful.
It makes AI much more versatile and accurate.
Okay, RAG check. Now let's talk about tokens.
Okay.
I know these have something to do with how AI processes language.
They do. Think of tokens as the building blocks of language from an AI's perspective.
Okay.
Instead of analyzing whole words, AI breaks them down into smaller units called tokens.
Okay, so it's like dissecting language into its smallest part.
Exactly. And the more tokens an AI needs to process, the more computationally expensive it becomes.
Ah, so that's why the source material mentioned token usage being a factor in the cost of some AI tools.
It is. Understanding how tokens work can help you use AI tools more efficiently.
Okay, makes sense. Now, transformer architecture. This sounds pretty complex.
It can be, but the key takeaway is this.
Good.
Transformer architecture allows AI to understand the relationships between words in a sentence,
Right.
not just the meaning of individual words.
So it's getting closer to how humans actually understand language.
Exactly. It's a game changer for natural language processing.
And that's why we've seen such amazing progress in language models like ChatGPT.
Absolutely, transformer architecture is a key innovation behind that.
All right, moving on to model weights. These are often described as the brains of an AI.
That's a good analogy. Model weights represent the knowledge and patterns an AI has learned during its training.
Okay, so it's like the AI's accumulated knowledge and experience.
You could say that they're numerical values that determine how the AI processes information.
And the source material mentioned Meta sharing the model weights for their llama model. Why is that a big deal?
It's huge. Sharing model weights is like giving others access to the AI's expertise.
Okay.
It can accelerate research and development
Ah, okay.
and make powerful AI technology more accessible.
Makes sense. So we've got the brains of the operation now. Let's talk about how those brains are built. Artificial neural networks.
All right. Artificial neural networks are inspired by the structure of the human brain.
Okay.
They consist of layers of interconnected nodes that
Yeah.
process information and learn from data.
So like a network of artificial neurons that learn and adapt.
Exactly. And the more complex the network, the more capable the AI.
I remember seeing an example of a neural network being used to recognize images in Google Photos.
Yeah.
Is that the same technology used in self-driving cars?
It is. Neural networks are used in a wide range of applications,
Okay.
from image recognition to speech processing to medical diagnosis.
Wow, they're everywhere.
They're a fundamental building block of many AI systems.
Okay, so neural networks are the structure, and model weights are the knowledge stored within that structure.
Right.
Now let's talk about parameters. They also seem to be related to an AI's learning capacity.
Parameters are the adjustable settings within a neural network.
Okay.
The more parameters a model has, the more nuanced its understanding of the world can be.
So it's like the resolution of a photograph, more pixels mean a sharper image?
Exactly. And the source material mentioned that GPT-4 has hundreds of times more parameters than its predecessor.
Wow, that's a huge jump. What does that mean for its capabilities?
It means GPT-4 can hold much more knowledge,
Okay.
make more complex connections between ideas, and tackle a wider range of tasks.
That's amazing. So we've got the structure, the knowledge, and the resolution. Now let's get into how AI actually learns, starting with supervised learning.
Right. Supervised learning is like teaching a child with flashcards.
Okay.
We give the AI labeled examples, and it learns by associating inputs with desired outputs.
So it's a very structured and guided approach.
It is. Think of it like showing an AI thousands of pictures of cats and dogs,
Okay.
each labeled correctly. So it learns to distinguish between them.
So it's learning by example.
Exactly.
Okay, what about unsupervised learning? How is that different?
In unsupervised learning, we don't give the AI labeled data.
Oh, interesting.
We let it explore data on its own and discover patterns without explicit instructions.
So it's more like letting the AI figure things out for itself.
Exactly. Think about how Google Photos groups your pictures into albums based on faces.
Yeah, that's pretty cool.
That's unsupervised learning. It's great for dealing with large and complex data sets.
This is all incredibly fascinating. We've covered so much ground already.
I know, right? We're just getting started, though.
I know, there's so much more to explore.
There is. We'll pick it up next time.
Awesome. Can't wait.
All right, so we talked about supervised learning and unsupervised learning, but there's another approach called reinforcement learning.
Reinforcement learning. Okay, what's that all about?
Imagine training a dog. You reward good behavior.
And discourage unwanted actions. Reinforcement learning is kind of like that.
So the AI learns by trial and error.
Exactly. It interacts with an environment,
Okay.
makes decisions, and gets feedback based on its actions.
So like in the source material AlphaGo, the AI that beat a world champion Go player.
Yep. AlphaGo learned by playing millions of games against itself.
Wow, that's incredible. So it's constantly learning and improving.
Exactly. It's a powerful technique for tasks that involve strategy and decision-making.
Makes sense. We've talked about how AI learns, but who controls that knowledge? That brings us to open source models.
Open source models are AI models whose code is freely available to the public.
So anyone can use them, modify them, distribute them?
Exactly. It's all about collaboration and transparency.
The source material highlights Meta's Llama model as an example of an open source model. What are the benefits of this approach?
Well, it accelerates research and development
Okay.
because everyone can contribute. It also promotes transparency, which helps address ethical concerns. Okay, so it's about democratizing AI and making it more accessible.
Precisely. It's about making AI a collective effort.
All right, let's shift gears to embeddings. I know they have something to do with how AI understands language, but
They do think of embeddings as numerical fingerprints for words and phrases.
like fingerprints for words. Interesting. How does that work?
They capture the meaning and context of words,
Okay.
allowing AI to understand relationships between them.
So instead of seeing words as just letters, AI can grasp their actual meaning.
Exactly. It's a key part of how AI understands and processes language.
Okay, so how do embeddings help AI perform tasks?
Well, they're crucial for things like semantic search,
Okay.
where you want to find information based on meaning rather than exact keywords.
So it's understanding the intent behind the words.
Exactly. They're also important for machine translation, text summarization, and a lot of other language-based tasks.
Okay, embeddings, got it.
Right.
We've talked about how AI learns how it understands language, and now we're getting into how it interacts with us. What are instruction-tuned models?
Instruction-tuned models are trained to follow instructions and complete tasks as directed.
So they're like AI assistants that can understand and execute commands.
Uncyclically. ChatGPT is a great example.
Okay.
You can ask it to write a poem, translate a document, even code a simple program.
And it will try its best to do what you ask.
Exactly. It's all about making AI helpful and versatile.
Okay, but even with all this sophisticated training, AI isn't perfect, right?
Sure.
Sometimes it makes mistakes or even fabricates information. That's where hallucination comes in.
Right. Hallucination is when an AI generates information that is factually incorrect or made up.
So it can sound very convincing, but it might be totally wrong.
It can.
Yep.
It's important to be aware of this limitation and not blindly trust AI.
So always double check the information, especially when it comes from AI.
Absolutely. Critical thinking is crucial.
All right, let's move on to some learning approaches that allow AI to adapt to new situations. What's the difference between zero-shot learning and few-shot learning?
Think of it like this. Zero-shot learning is like asking someone to perform a task they've never been trained for, but they manage to figure it out based on their general knowledge.
Okay, so it's like figuring things out on the fly.
Exactly. Few-shot learning is similar, but we give the AI a few examples to guide it.
So it's like giving someone a quick tutorial before they try something new.
Yeah, it helps the AI learn new tasks more quickly and efficiently.
Now let's zoom out and talk about LLMs, or large language models.
LLMs are the foundation of many impressive AI applications.
Yeah.
They're trained on massive amounts of text data, which allows them to understand and generate human-like text.
So ChatGPT, Claude, Gemini, these are all LLMs, right?
They are. They can hold conversations, write stories, summarize documents, and much more.
What makes them so powerful?
Their vast knowledge base and their ability to process language in a nuanced way.
So it's the combination of knowledge and language skill.
Exactly. And they're constantly evolving. We can expect even more impressive things from them in the future.
It's exciting to think about the possibilities.
Yeah.
Now let's get a bit more technical with MOE, or mixture of experts.
MOE is like having a team of specialists,
Okay.
each with their own area expertise.
Okay, so different parts of the AI model are specialized for different tasks.
Exactly. When a request comes in, the system activates the most relevant experts.
So it's like having the right tool for the job.
It is. It improves efficiency and reduces computational costs.
Okay, so it's about making AI smarter and more efficient.
Exactly.
We've talked about AI that can understand and generate text, but what about images? That brings us to diffusion models.
Diffusion models have revolutionized AI-generated art.
Okay, how so?
They work by starting with random noise
Okay.
and gradually refining it into a coherent image.
So it's like a painter, starting with a messy canvas and then slowly creating a masterpiece.
That's a great way to put it. Popular AI art generators like Stable Diffusion and DLE use this technique.
Wow, that's incredible. So you can literally ask the AI to create any image you can imagine.
Pretty much. It's amazing what these models can do.
Okay, so we've talked about different ways AI can learn and adapt, but how do we make sure it aligns with human values?
Well, that's a crucial question, and that's where RLHF comes in, which stands for Reinforcement Learning from Human Feedback.
RLHF. Okay, tell me more about that.
It's about incorporating human feedback into the learning process,
Okay.
rewarding the AI for generating responses that are helpful, accurate, and appropriate.
So it's like having a human coach guide the AI's development.
Exactly. OpenAI used RLHF extensively to train ChatGPT, making it more polite, helpful, and less prone to generating harmful or biased content.
So it's like we're teaching AI not just to be smart, but also to be a good citizen, you know?
Exactly. We want AI that's beneficial to humanity.
Yeah, AI that aligns with their values. Okay, that makes me feel a bit better about the future. Now for our final term, multimodal models. What's so special about them?
Think of them as the ultimate AI multitaskers.
Okay, multitaskers.
How so?
They can process information from multiple sources, not just text.
So like the source material mentioned GPT-4V, which can understand images.
Right, GPT-4V is a great example of a multimodal model.
Okay, so it can analyze pictures, answer questions about them, even generate captions.
Exactly. It's expanding the possibilities of AI interaction and understanding.
Wow, that's pretty amazing. We've covered a lot of ground today, from the hardware that powers AI to the models that are pushing the boundaries of what's possible.
We have. But hopefully this deep dive has given you a solid understanding of the key terms.
It definitely has for me. And remember, this was tailored specifically for you guys based on the terms you wanted us to cover.
Exactly. We wanted to make sure this was relevant and useful for you.
So if you're feeling a little bit more fluent in AI now,
I hope so.
it's all thanks to you guys for sending in your questions and for tuning in. It's been a pleasure exploring these concepts with you.
And remember, if you want to keep learning more about AI, make sure you subscribe to Le Podcast de Philippe on YouTube. Help us reach 1,000 subscribers today. Until next time, stay curious and keep exploring.